Okay, so we are going to be talking about basic differentiation properties. So we have notation, the derivative. If y is equal to f of x, then we have the f prime of x, y prime, dy dx. They all represent the derivative of f at x. So this is the derivative with respect to x. So each of these derivative symbols has a particular advantage in certain situations, but they all mean the same thing. So we have the constant function rule. These are, we've got the power rule, the multiple property, and the sum and difference property. So the derivative of any constant function is going to be 0. We've talked about this already. Um, so hopefully you have an idea of that. So it's just saying that if the function equals a constant, then your derivative, no matter which way it looks, is going to be 0. The power rule is where we have like x to a power, then where n is going to be a real number. That means that um, sorry, um, we have we take the power, we bring it up front, and then we're going to take our x to the n minus 1. So we're going to subtract 1 degree. So if we had like an x squared, this will come down to be 2x, and then 2 minus 1 would get us 1. And that's going to work for all of them. We also have the constant multiple property, where if we're multiplying by a k, which is our constant, then you have your derivative here, and basically if we have it of this function, then we're taking that constant is being multiplied by the derivative of the function. And then we have our sum and difference properties. So if we have two functions that are added and subtracted, then if we have the derivative, it's going to be the adding and subtracting of those derivatives, depending on if it's being added or subtracted. And again, the notation doesn't matter. This rule applies to the sum and difference of any number of functions, so it can be more than just two. All right, so let's go get started. We're going to find some derivatives of the following functions or expressions. So if you're in my class, we're in our current book. We're looking at section 9.5, but also known as differentiation, right? All righty. So for example 1, we are looking at constant functions. So for A, if we have f of x equals 3, then our f prime of x, or the derivative, is going to be equal to 0. That's by that constant part. If we have y equals negative 1.4, then our y prime is still equal to 0. Let me box those answers so you know that is the actual answer. All right, if we look at C, then we have y is equal to pi. Now, pi is still a constant. It is a never-ending one, but it's got a lot of values. But we can write this one as, let's go with a different color, dy dx, the derivative of y with respect to x, is still equal to 0. And then for d, if we have d dx of 23, that's already put into our derivative form, it's still going to equal 0. Anything that is a constant, a number, right? Okay, let's go to example 2. So for example 2, we are going to talk about power functions. So we've already talked about the rules. So A, if we have f of x is equal to x to the 5th, then our derivative is going to be the power. So the power is 5, comes out to the front, and then we're going to have to the 5 minus 1, which will get us 5x to the 4th. All right, let's look at B. We have y is equal to x to the 25th power. This will get us y prime is equal to our power, and then x to the power minus 1, which will get us 25x to the 24th. All right, C. We have y is equal to t to the negative 3. So this will get us dy dt, because this one's with respect to t, is equal to negative 3 t to the negative 3 minus 1. So this will get us negative 3 to the negative 3t to the negative 4. So it doesn't always have to be x. All right, and then d, we have d dx of x to the 5 thirds. Almost didn't get my fraction right there. And that will get us our power of 5 thirds x to the 5 thirds minus 1. Now, to subtract fractions, we've got to have common denominator. So this will get us 5 thirds x to the 5 thirds minus 3 thirds. We have a common denominator. And that'll get us 5 thirds x to the 2 thirds. All right. Let's go on to example 3. We're going to look at power functions some more. They're just a little bit different. So for A, we have f of x equals 1 over x to the 4th. So what we're going to do is we are going to rewrite our function. And it's going to become f of x is equal to, because it's in the bottom and it has a positive exponent, when it crosses this line, it will change the sign to negative. So we're going to write it as x to the negative 4th, because that way we can do our differentiation. So this will get us f prime of x, grab the wrong pen, equals negative 4x to the negative 4 minus 1, which will get us negative 4x to the negative 5th, but we want to write it with positive exponents. So this will become negative 4 over x to the 5th. And that would be our answer on this one. All right, let's go to B. So for B, we have y is equal to the square root of u. Again, we are going to rewrite. And that is going to be y is equal to u to the 1/2 power. If it was like a cubed root, it would be 1/3. So now we can do our y prime. The y prime is equal to 1/2 u to the 1/2 minus 1. Again, we need that common denominator. So that is going to get us 1/2 u. Now you could make that 2 over 2, or you can understand that if you are subtracting 1/2 from 1, you get the negative 1/2. You can do it either way. Minus 2 over 2 will get us 1/2 u to the negative 1 over 2. Now on this, we got to, again, write it as a positive exponent. So this is going to become 1/2 u to the 1/2. I did not write that very well at all. I had to put that all underneath my denominator. And basically that 1/2 is going to become back into a square u. square root. So 1 over 2 square roots of u. And it all depends on what homework you're looking for to whether they're looking for this or this. So pay attention to what answer they're okay with. And I'm using different ways just so you see it doesn't matter which way you do it. Um, they're all the same. I could have this function and write it as y prime because f of x is the same thing as y. All right, let's look at C. I don't think we have enough space on this page, so let's go to the next page. All right, so C, we have d dx of 1 over the cubed root of x. I kind of mentioned a little bit about what that might look like. So if we have that, this is going to be equal to d dx of, if we follow what we did on this one, we took it to the 1/2, right? But this one's down below underneath. So this would be 1 over x to the 1/3 power, but then we're going to rewrite it again because we actually need it up top. So we'll have d dx is equal to x to the negative 1/3. So we need it to become exactly what we're looking for. So you're just going to rewrite. All right, so this is going to equal negative 1/3 x to the negative 1/3 minus 1, which will be negative 1/3 x to the negative 1/3 minus 3/3, which will get us negative 1/3 x. Negative 1 minus 3 will get us negative 4/3. Again, we don't want to leave them with negative exponents. So this will become 1 over 3 x to the 4/3. Now, the bottom part is your index for your radical. The top part sticks to the exponent. So this will become 1 over 3 cubed root of x to the 4th. That would be your final answer on that one. All right, let's go look at example 4. We're looking at a constant times a function. Making sure I wasn't missing anything that was on the handout, but nope, we covered. All right, so we have f of x equals 3x squared. So if we're looking at our derivative, we will have f prime of x equals 3 times, now we got to take the derivative of our x squared, which would be 2x, and that is to the 2 minus 1. We won't always write these because we're going to eventually get the hang of this. So that gets us 3 times 2 would be 6x. And 2 minus 1 just gets us an exponent of 1. All right, B, we have y is equal to t cubed over 6. So we can rewrite that as 1/6 t cubed. That way it doesn't look like a denominator. Now we can write this one we have dy dt, because we're with respect to t, is equal to 1/6 times 3 t to the 3 minus 1. Now, what I tell my students all the time that can be very helpful when we're dealing with this is you can write this over 1. That way you understand that 3 is on the top, this 6 is on the bottom. So that is going to get you 3 divided by 6, which would be 1/2. So this will become 1/2 t. 3 minus 1 will get us 2. All right, let's look at C. We have y is equal to 1 over 2x to the 4th. Again, we need to rewrite that. So we have 1/2 x to the negative 4, because it's coming from the denominator up to the numerator. So now our y prime will equal 1/2 times negative 4x to the negative 4 minus 1. So this will equal, we have 1/2 times negative 4, that's negative 4 divided by 2, would get us negative 2x to the negative 5, because negative 4 minus 1 will get us negative 5. Again, positive exponents will get us negative 2 over x to the 5th. Right, let's do D. D, we have d dx of 0.4 over the square root of x to the 3rd. This will become d dx of 0.4 over x to the 3/2, because that index will end up being in the denominator of your exponent. So this will be d dx 0.4 x to the negative 3/2. All right, now that we have it rewritten, let's go find our derivative. So this is going to equal 0.4 times our negative 3/2 times our x to the negative 3/2 minus 1. All right, so now we have 0.4 times that negative 3/2. Let's go ahead and get us some common denominators. X to the negative 3/2 minus 2/2. That's the same thing as 1. So this will get us 0.4 times negative 3/2. And you could go ahead and multiply that early, but I'm just trying to work one part at a time. So negative 3 minus 2 will get us x to the negative 5/2. So 0.4 times negative 3/2, you can just put that in the calculator. You're going to get negative 0.6. And then we have our x to the negative 5/2. Well, that is going to need to go into our denominator. Let me go ahead and just show you. So this will become negative 0.6 over x to the positive 5/2, which will get us negative 0.6 over the square root of x to the 5th power. All right, now let's go to another type. We are going to do example 5 will be the sum and difference. So sums and differences. All right. So our first example, we have f of x equal to 3x squared plus 2x. So I can do my f prime of x will be equal to the derivative of 3x squared plus the derivative of 2x. All right, so this will get me 3 times my x squared will become 2x. We're not going to, so this will become 2x, and it'll be 2 minus 1, right? So 2 minus 1 will get us 1. So I'm not going to write every little step. We've done a few of those now. Plus, we're going to have our 2 times, this will be x to the 1, so it's being multiplied by 1. We don't have to write the 1. But this will become x to the 1 minus 1. I want to make sure you understand what happens there. So this will become 6x plus 1 minus 1 will get you 2x to the 0. So what does x to the 0 equal? That is equal to 1. So this will be 6x plus 2 times 1, which will get us 6x plus 2. I wanted to make sure you could follow why this one, the x's go away. All right, let's look at B. We have 4 plus 2x cubed minus 3x to the negative 1. So again, our y prime. Oh, and I forgot to write the y equals. That's a y equals equation. So y prime will be equal to our 4 derivative, right, plus our 2x cubed derivative minus our, because there's a minus sign, 3x to the negative 1 derivative. So those are derivative symbols. They are not first powers, just so you know. Scooch this up just a little bit. All right. So let's work on that derivative. The derivative of 4 will be 0. This will become 3 times 2. So we have our 2. Our 3 comes out, and this will become x squared, because 3 minus 1 will get us 2. Minus, we have our 3. The exponent comes down as a negative 1, and then this will be our x to the negative 1 minus 1. All right, so 0 goes away. We have 2 times 3. That will get us 6x squared. A negative 3 times a negative 1 will be a positive 3. And then this will be x to the negative 1 minus 1, which will be x to the negative 2. So we will have 6x squared plus 3 over x squared. Again, positive exponents in your final answer. All right, let's look at C. C, we have y is equal to the cubed root of w minus 3w. Again, we can use all kinds of variables. All right, so this we need to be as w to the 1/3. So we can write this as w to the 1/3 minus 3w. That way we're all good to go. All right, so let's look at our dy dw, because again, we're doing it with respect to w, is going to equal, and we can write this anyway. We've done the little prime things. If you prefer, you can write this as d dw of our w to the 1/3 minus, because it's a minus sign, d dw of 3w. And because we put the negative there, we won't put it there. So that means we're going to subtract, because this is subtraction, our two derivatives. So you can do it with the little prime guys, or you can do it this way, whichever you prefer. It really doesn't matter. All right, so this will become 1/3 w to the 1/3 minus 1. Now what I'm going to do is go ahead and write my 1 as a common denominator of 3 over 3. So I don't have to rewrite as much. And you can always do that, or you can do that math in your head, whichever way you want to go. So this will, oops, I got to do subtraction. So minus, we have to do the derivative of this. So this will be our minus 3 times w to the 1 minus 1, which we know will become 0. So this is going to equal our 1/3 w to the negative 2/3 minus 3 times 1, because w to the 1 minus 1 would be 0. That's going to get us a times 1. So now that negative 2/3 has to go in the denominator. So we will have 1/3. Let's see. Let's make it a little bit better. So we have 1 over 3 w to the 2/3 minus 3. And our final answer, we need to write that in the radical. So we'll have 1 over 3. This will be the cubed root of w squared minus 3. That will be our final answer. Sorry about the little oopsies. Pen does not erase. All right, let's go do another problem. So for D, we have d dx of 5 over 3x squared minus 2 over x to the 4th plus x cubed over 9. All right, so we've got to write this as all the exponents are up on the top level. So this will become our d dx. This will be 5/3 x to the negative 2 minus 2 x to the negative 4 plus we'll have 1/9 x to the 3rd. All right, so now we can see that, and if we're going to need to parenthesize all of that so we understand it is all being taken the derivative of. All right, so this will get us d dx. We're going to have to do each part. So we have 5/3 x to the negative 2 minus d dx of 2 x to the negative 4 plus 1/9, oops, sorry, d dx of 1/9 x cubed. And you could have, instead of rewriting that, we could have just gone ahead and put all the d dx's next to them. Sometimes I think doing the little prime is a little bit less effort. All right, so let's go find those derivatives. We're going to have our 5/3 times the negative 2 times our x to the negative 2 minus 1 minus 2 times our negative 4 times x to the negative 4 minus 1 plus 1/9 times 3. And I'm going to go ahead and write that 3 over 1 so we can make sure we pay attention to where those numbers are aligning. And then we will have our x to the 3 minus 1. So in the past, I didn't separate them all, but you can write them this way. I'm just giving you options. It's all multiplication, so parting them out is just fine. All right, so now we have 5 times negative 2 will get us negative 10 over 3, and this will get us x to the negative 3, plus 2 times negative 4, negative 2 times negative 4 will get us a positive 8, x to the negative 5, and then we have 1/9 times 3 over 1, so that will take us down. The 3 will reduce the 9. We'll get 1/3 of x squared. All right, again, writing it all in positive exponents, we will end up with negative 10 over 3x cubed plus 8 over x to the 5th plus 1/3 x squared. Or you could write that as x squared over 3. Either way you want to do it. because they did have it over 9. It doesn't matter because the number being underneath um, it's not about negative exponent, so it doesn't matter. All right, let's go on to example 6. All right, so for example 6, we're just going to find the derivative. So we have f of x equals 1 plus x squared over x to the 4th power. So first thing we want to do again is rewrite this. So we're going to put each part over the exponent. So we're going to have 1 over x to the 4th plus x squared over x to the 4th. Well, we need to, again, rewrite things here. This will reduce because we have 2 on the top and 4 on the bottom. This will become, I'm going to do this one at a time here. So we have x to the 4th plus 1 over x to the 4th plus 1 over x squared, because 4 minus 2 will get us 2, because again, when it crosses the line, it'll change its sign, so that'll become a negative 2. All right, now we want to write these as x to the negative 4 plus x to the negative 2. So now we can take our derivative of that. We've just rewritten our function going across there. So this is kind of where we're at, where we're going to take our derivative of that. So we'll have f prime of x will be negative 4 times our x to the negative 4 minus 1. And then we'll have plus, that'll become negative 2 x to the negative 2 minus 1. Now I wrote the plus because it was positive, but you could recognize, hey, that's going to become a negative 2 and write it just as negative 2. Either way works. All right, let's simplify this down. This will get us negative 4x to the negative 5 minus 2x to the negative 3. And then, of course, we need to write it with positive exponents. So this will become negative 4 over x to the 5th minus 2 over x cubed. And that would be our derivative. All right, let's go to example 7. Now, for example 7, we've got a little bit of because we are in business math, a little bit of a word problem. So we're talking about instantaneous velocity. An object moves along the y-axis marked in feet, so that its position at the time x, which is in seconds, is f of x equals this. We're going to find the instantaneous velocity of function v and the velocity at x equal to 2 and x equal to 5 seconds, and then we'll find the time when the velocity equals 0. So when we're talking about the instantaneous, we learned in the previous section that that meant we were finding the derivative. It's the instantaneous rate of change. All right, so here is our function. We have f of x equals x cubed minus 6x squared plus 9x. So for part A, we want v to equal our f prime of x. That's what we want to find. So let's do our thing. Now we're going to take the derivative of each part. So that means, and you don't necessarily have to write every little step that I do, but I want to make sure you understand where things are coming from. So we have x cubed to the prime minus 6x squared prime plus 9x prime. So this will become 3x to the 3 minus 1. And again, you could just start writing that as 3x squared minus 6 times the 2 to the x of 2 minus 1 plus we'll have 9x to the 1 minus 1. This will get us 3x squared Negative 6 times 2 would get us negative 12 x to the first power. And then this will become x to the 0, which is the same thing as 1. So plus 9. That is our derivative. All right, part B, as we read, we are looking to find the velocity at x equal 2 and x equal to 5. So that means we're looking at f prime at 2, and f prime at 2 is going to be this, because that is our derivative right there. We're going to plug in 2. So I'll have 3 times 2 squared minus 12 times 2 plus 9. Now you can work this out, or you can put this in the calculator. This would get us 3 times 4, 12 times 2 would get us a negative 24 plus 9. So that's 12 minus 24 plus 9 will get us a negative 3. And that is feet per second. So again, if you just want to put that in the calculator, you can. Sometimes I like to do the mental math. And then we also need to find our f prime at 5, because those were the two values they asked. So this will be 3 times 5 squared minus 12 times 5 plus 9. I'm just going to tell you that that is going to end up being 24. So that's 24 feet per second. So that is our instantaneous changing that's happening at those exact values. All right, and then we had part C. And part C said to find the values of x, oops, sorry, wrong problem. Find the time when the velocity equals 0. So if we want to find the time where the velocity is equal to 0, we're going to take our v, our velocity, which is the f prime of x, which is equal to 3x squared minus 12x plus 9, and we're going to set it equal to 0. Now, this is going to require us to do some algebra. So I'm noticing that all three values have a common factor of 3. That can make it easier for us to factor if we can find out anything common that we have first. So 3x squared divided by 3 will get us x squared. Negative 12 divided by 3 will be negative 4x, and 9 divided by 3 would be plus 3. Now the 3 won't change anything because it doesn't have a variable, but now we need to factor this. So hopefully you know how to factor. If not, I have videos about factoring, but I'm not going to do the factoring here just to save us some time. Now we're going to set each part of those equal to 0. So x minus 1 equals 0 and x minus 3 equals 0. We will add the 1 to both sides and get x equal to 1, add the 3, and get x equals 3. So the velocity is 0 at x equals 1 and x equals 3 seconds. Those are the times. All right. Now let's go to example 8. So for example 8, we're looking at another function, and we're going to find 3 things with that one as well. All right, so for example 8, we are given the function of f of x, sorry, you can't see, f of x equals x to the 4th minus 6x squared plus 10. So for A, we are going to find the f prime of x. So we're looking for the derivative. All right. So our derivative is going to be equal to, we've got 3 parts here again. So we're looking for the derivative of this minus the derivative of this plus the derivative of 10. So this will get us 4x to the 4 minus 1 minus 6 times 2 times x to the 2 minus 1. And then the derivative of a constant we learned at the beginning is going to be 0. So that is going to go away. So this will get us 4x cubed minus 12x, because 2 minus 1 will get us 1. So here's our derivative. Now for b, we are asked to find the equation of the tangent line at x equals 1. So the equation of a line is y minus y1 equals the m times x minus x1. And we're asked to find that at x equals 1. So we need a point and we need a slope because this is the point slope formula. So we're asked to find at x equals 1. So let's find our point first. This will be where we find f at 1. So we're going to use our original function. We are not going to use the derivative. We're going to use the original function. So f at 1 will be 1 to the 4th power minus 6 times 1 squared plus 10. So that'll get us 1. 1 squared is 1 times 6 will get us minus 6 plus our 10 will get us a total of 5. So that makes our point at 1, 5. That's the point we need for our thing. Now we need to find the slope. Now the slope is going to be using our derivative at the point we're looking for the slope. So we are going to find the m is the f prime at 1, the derivative at 1, which will get us 4 times 1 cubed minus 12 times 1. Well, 1 cubed is going to be 1 times 4 is just 4. Negative 12 times 1 will get us negative 12, and 4 minus 12 is negative 8. So this tells us that our m will be equal to negative 8. All right, so now that we have the information, we can use our formula. So we are going to have y minus, this is our x1, y1 right there. So y minus 5 equals negative 8, which is our m, times x minus 1, because our x1 is 1. All right, let's distribute. We have y minus 5 equals negative 8x plus 8. So this is our, using our algebra skills. Now we're going to add our 5 to both sides. We get y is equal to negative 8x. 8 plus 5 is 13. So that is the equation of the tangent line at x equal to 1. All right, we have one more part. Part C, we are looking for the horizontal line. It says find the values of x where the tangent line is horizontal. So a horizontal line has, my end does not look very good, sorry, has a slope equal to 0. That slope doesn't look very good either. Sorry about that. So that means for our f prime of x will have to be equal to 0 because that's our slope when we're dealing with these types of functions. So that means we're going to go get our function, our derivative. So we'll take our f prime of x, which is 4x cubed minus 12x that we found in the first part, part A, and set it equal to 0. Again, let's look at what they have in common. They both have a 4 and an x, so that will leave me with x squared minus 3 equal to 0. And we're going to do the same thing we did before. We're going to take each part and set it equal to 0. Divide by 4. we get x equal to 0. Here we're going to add 3. This does not factor, so we're going to add 3 to both sides and get x squared equals to 3. We'll take the cubed root of both sides and get x is equal to plus or minus the square root of 3. So remember, anytime we introduce a radical, we have to do that plus or minus still. So we will have x equals to 0 and x equals the positive square root of 3 and the negative square root of 3. And that is where the values of x, where the tangent line is going to be horizontal.